Hello and welcome back to CES 2026. We're here live from Las Vegas. And again, really diving into what's going on with some of the new and innovative stuff that's been announced here live at the NVIDIA keynote that they're doing at the Fontainebleau. And I'm joined by one of my friends here, John Mile, who's the VP of Strategic or Global Strategic Alliances for Vast Data. You guys were on there. You were in there. You had your logo up on there, and there was some really interesting stuff when they got into the Vera Rubin entire, I would say, system. Because I wouldn't call it a chip because it's many chips and it's many systems. But why don't you kind of help us understand and help people understand and unpack this, how you're playing with the context storage portion of Vera Rubin?
Yeah, I mean, I think Jensen did a great job explaining how they had to reinvent the entire system, right? It's not just a new GPU, but 6 different chips like you mentioned. And I think a lot of that also spills into the rest of the stack, right? And the rest of the stack in this context, no pun intended, is reinventing how you do things like KV cache, right? And how do we evolve when models get bigger, when longer reasoning starts to happen, when there's more turns that are happening on inferencing. That means that different paradigms required for storing KV cache. KV cache used to be very kind of local to the GPU, to the memory, to the high bandwidth memory, HBM, on a particular node. But obviously that's not good enough if you're trying to store very long conversations. If you're trying to grow that context over time, you need a different method, right? And so a lot of that development that VAST has been doing with NVIDIA is in how do we build and re-architect that part of the stack for these new systems that are going into deployment.
Yeah, which makes total sense with the VAST OS, the AI OS, and where you're going with this and how you're really bringing things together. But like you said, you hit on it a little bit. People have been really investing in and using KV cache and using things like NVMe inside the servers. Help people understand how this is different from that and how they can gain, because Jensen showed some pretty impressive gains in reasoning with Vera Rubin.
Yeah, so I mean, using local NVMe SSDs as part of a GPU server is one way to extend and kind of grow that KV cache. But the other way to do it, especially given all of the innovation that NVIDIA is doing on faster networks, innovations like Spectrum-X networking, also DPUs like the BlueField-4, which is a very cornerstone part of the announcement today, it allows us to think about, could we build an even more scalable context cache outside of the physical GPU server? So spilling out across the network, doing that in a high bandwidth, low latency way is instrumental. So yes, local NVMe is good, but imagine a world where you had an infinitely scalable pool of NVMe across a very fast fabric, being able to do that. And that's part of the announcement today.
Yeah, and helping feed those GPUs, because as we know, the AI only goes as fast as the data goes and that. So yeah, you hit on the BlueField-4 and things of that nature, and that has to be a piece of it, is moving that data very quickly, and you have your shared everything architecture that really scales that way. Has that been what your customers and what you've been hearing from the customers?
Yeah, we've been partnering with NVIDIA on BlueField for, gosh, many years now. Like, we've been using BlueFields in our designs and our systems since the first generation, BlueField 1s, right, back in the day. And part of what was really cool about the announcement today is not only kind of the direction of this is coming, but we've actually, I think we're the first one to actually validate an end-to-end BlueField solution for context memory, being able to extend that context memory across the wire, across the network. So BlueField-4 becomes kind of an end-to-end solution from us, not only to house the SSDs, the NVMe SSDs on the other end of the network, but also to run a lot of the vast AIOS software inside of the GPU machine while giving you crazy good bandwidth performance using RDMA for low latency access straight back into GPU HBM.
Yeah, I mean, I look at this, I mean, obviously it's Consumer Electronics Show, CES. You're going to be on a panel on Wednesday. Kind of talk a little bit to that, because I think, you know, you have so many customers in so many different fields that actually touch the consumer.
I think I saw somewhere, I forgot who posted it, someone from NVIDIA, but yeah, this is a consumer electronics show, but the data center touches the consumers indirectly when it comes to AI. So we're seeing AI, as everyone knows, it's infiltrated every single industry, right? Sports and media is obviously a big market when it comes to unstructured data around video, leveraging AI to be able to understand what's happening in video. Being able to democratize that access is game-changing for a lot of organizations, including in media entertainment, right? So yeah, we're super excited. We're working here at VAST, not only in media entertainment, but you name it, right? Whether it's in robotics and physical AI, it's becoming a we saw Jensen talk about it for the first 45 minutes today, right?
Right.
It's becoming a material part of the AI story in the market. But also your classic enterprises are starting to move AI into production more and more increasingly. So things like KV Cache, again, come full circle, become an instrumental part of that design moving forward.
Absolutely, and I think that to me, that was the biggest announcement out of the Vera Rubin was the context storage and being able to bring that and have it more centralized and feed out over super low latency, high bandwidth. And I think to me that was great. Last parting thought.
I haven't been to CES in quite some time, so I'm just very excited to check out. Jensen always does a bang up job. I think one of the things that was maybe skirted over, at least for me in the past, was the improvements on just how they've also changed the physical packaging from generation 1 of their supercomputing with Grace Hopper, Grace Blackwell to Vera Rubin. Just the simplification, going from 2 hours of manufacturing to 5 minutes. I'm super excited just to see this progress because it's going to be an accelerant for the industry to adopt some of these supercomputer technologies moving forward.
Yeah, like you said, completely water cooled, and they brought the water with them from California apparently. So, it was having a little bit of trouble moving around. But yeah, great having you on, John. Thanks for coming by.
Appreciate it.
And thank you for watching this segment. We'll be back with more from CES 2026. Stay tuned.